Everyone, let's start. Ritu, Advik, Dhriti, Astha, Spriha, Meha. So if you recall, all of you, in the last class, we were talking about, it was a combined class, Newman and Sauer's projections we have done. We reviewed symmetry elements. All those things were done, right? Are you okay with these things? Which you had discussion in the last class. We have to practice a lot of things, right? That's what we said. We'll practice, understand all these conversions, interconversions, Element of symmetry was discussed. Chirality as a term was discussed in that class. What is meaning of chirality? No, I'm pretty sure that we have not done this in your class, right? Can you confirm, please?
Yes, sir. No, sir,
Done
we
or not?
haven't.
We have not, no? Yeah, correct. So I'll just give you a quick review of what all we have discussed so that you come back to the same point where we left the last class. So there are three elements of symmetry. Can be center of symmetry, plane of symmetry, or axis of symmetry. Center of symmetry, plane of symmetry, or axis of symmetry. How many plane of symmetries are there? 9. How many axis of symmetries are there? 13. And how many center of symmetries are there? Total, it becomes 23. 23 element of symmetry. Okay. So now, can you recall what is axis of symmetry? In the last class, we talked about draw some axis around which the whole structure is symmetrical. Okay. What is center of symmetry? A central point about the whole thing is symmetric. Plane of symmetry. A plane about the whole thing is symmetric, right? That's a plane of symmetry. Advik, can you recall these things? Jia is not here. Tarun, who is joining with Redmi? So Iha is here. Tarun, okay. Tarun, I think till this point we have done, right?
Yes, sir.
Okay, great. So write down optically active or optical active means this is if and only if it does not consist of any POS or COS. Like बहुत important line है. Any compound is optically active if it does not consist of any POS or COS. Advik, what is POS?
Sir, I don't know.
Last class you were there, right?
Yeah, sir, but then.
What is POS? Plane of symmetry.
Oh, okay, fine. Yeah.
Please turn on the camera also. COS is center of symmetry.
Yeah.
Okay. So if you recall this discussion, if this is a cube, okay, In the cube, let's say we take this particular plane, which is cutting it from the middle, something like this. It's a plane of symmetry. This is a plane of symmetry. Okay. Even this is a plane of symmetry. All right. Advik, is that clear? Center of symmetry is center of the cube. That makes sense? So now, if and only if does not consist of this, that means the reverse of it. If we prove that the compound is carrying a POS or a COS, आपने prove कर लिया कैसे भी करके कि वहां पे एक plane of symmetry है structure में or a center of symmetry, it is definitely optically inactive. Don't you think it is making your job easier? If a compound is carrying any plane of symmetry or a center of symmetry, okay, और है, दोनों prove करने की जरूरत नहीं है. Either you prove plane of symmetry or you prove center of symmetry. It will become optical inactive or optically inactive. So with this logic, can I say no planar structure could be optically active ever? Because any planar structure, anything which is in one plane, I will take this plane as a, what do you call, plane of symmetry. I'll consider the symmetry about this plane itself in which the compound is lying, which is also called sandwich plane of symmetry. So let's say any planar compound is there. Any planar compound is having its own plane of symmetry on which plane the compound is lying. Hence, any planar compound is always optically inactive. Can you find any planar compound which is optically active? Answer is no. And why answer is no? Because planar compound is having plane of symmetry. Where is the plane of symmetry? I'll say the plane itself in which the compound is lying. Okay. So anything which is planar, you can just pick this plane itself and say, see, the whole compound is symmetric about the plane itself because everything is in the same plane. I don't find anything which is above plane or below plane or something like that. Right? Let's start certain questions here. Draw minimum carbon alkane that is optically active. So what is the definition of optical activity? If you recall, we discussed what is the definition of it. Based on that, try to draw. Draw minimum carbon alkane that is optically active. कैसे करोगे question? So you have to make it optically active. You should have 4 different groups.
So can you again explain it?
Yeah. So what is optical active? When you have 4 groups which are different, then it is optically active. We put a star, we write G1, G2, G3, G4. Can you recall the last class discussion? How anything is optically active? How anything is chiral? If you have 4 different groups. ये तो किया आप लोगों ने भी? Yes or no?
Yes.
So how do you put 4 different groups on alkane? Alkane is having carbon and hydrogen. So you have to have minimum carbon. So I put hydrogen only. I'll save 1 carbon. Then next we can put CH3. 1 carbon is used. Tarun. Then after 1 carbon, what can we write next? Can we use 2 carbons? CH2, CH3. Then maybe we can use 1 more carbon. So you have to ensure that the carbon is having 4 different groups. How many such carbons are needed to do that?
Sir, 6 carbons.
Okay, 6 others.
Sir, when we are talking about 4 different groups, that can be like alcohol can also be there, right?
No, alkane. It is alkane, not alcohol.
There's a
Alkane
minimum
means
5.
carbon, hydrogen.
No, sir, and the groups that we're putting on the chiral carbon.
We can't put. We have to draw only alkanes. We have to draw only alkane means hydrocarbon. We can't use any other group, right? Yes, Tarun.
The 5 carbons.
5 कार्बन से कैसे करेंगे आप? एक कार्बन तो सेंटर में हो गया, एक H हो गया, one more C2, then 2 carbons, then 3 carbons. So total कितने हुआ? If 2 carbons are same, then it will not be optically active. Okay, see the structure. Answer is 7 because I'll put one carbon first of all, around which I have to make optical activity. One hydrogen to minimize carbon, then one CH3, then one CH2, CH3, then one CH2, CH2, CH3. Total how many? 1 plus 2 plus 3. कर लेंगे. And plus ये वाला तो है ही, इसको भी तो चाहिए. ये काम भूल जा रहा. Total how many are coming up? Thriti,
So 7.
is it clear? Any problems in this? Any issues? Advik, is it clear to you?
Sir, I did not get optically active part.
Optically active.
Yeah, like from this part only, I didn't get it.
Okay, so you were there in the last class.
Yes, the last class I was there, but then the optical active parts I didn't get, which you just explained.
This part you were there in the class when I discussed in the last class.
Yeah, this one I was there. Yeah.
That's what we are just repeating. Optical active, chiral, or asymmetric center is one when the carbon has 4 different groups. Or nitrogen plus has 4 different groups. Now, how can you put 4 different groups? Just think that. How can you put 4 different groups which are only allowed as carbon and hydrogen? Draw कर, खुद draw करके देखो.
And then the groups have to be different. They can't be same now.
यही तो rule है. G1, G2, G3, G4. Groups have to be different. So you'll have carbon, you'll put hydrogen, you'll put one carbon. And next time, if I put one carbon that is optically inactive, that doesn't solve the purpose. I have to put 2. Next time, I have to put 3. So total, how many carbons we have used? 3 plus 4 plus 1, 5 plus 2, 7. That's all. Easy. Hai? Ritu, is it clear? Next question, can all of you answer, please? Minimum carbon alkene that is optically active. Draw minimum carbon alkene. Kariye, draw kariye. Done. How can we draw?
So will there be 6 carbons?
Very good. Now this time you can cut down 3 carbon, make it C double bond C. So this is an alkene, see. So one place I put double, one place I put single. But both the places 2 members. This way you can save 1 carbon. Are you understanding this part? So we are drawing an alkene, which is having a double bond. A carbon with 4 different groups. And this are not same because one is single, other is double. Is it clear? So because of alkene, I could save 1 carbon. Last time I have to draw 3 carbons. This time I'm drawing just 2 carbons. Make sense?
Yes, sir.
How many of you understand this? Raise your hand, please. Good. Next question. Draw minimum carbon alkyne that is optically active. And these things are questioned at some point of time. So we should be thorough with this, right? Draw minimum carbon alkyne that is optically active.
Sir, it will be 6.
Others, please try.
6.
आ रहा है सभी का 6. स्ट्रक्चर अब ऐसे बना पा रहे. This time it is alkyne. Alkyne means triple bond. Advik, clear? So we are saving carbon because of a triple bond. And it is alkyne. Yes, it is alkyne because it is carrying a triple bond. Answer will be 6. If you try anything less than 6, it's not going to happen, right? Next question. Minimum carbon hydrocarbon that is optically active. Now this time I'm writing hydrocarbon. I have given you full choice. You can draw alkane, you can draw alkene, you can draw alkyne, you can draw a mix of it. The only condition which I'm worried for is it should be hydrocarbon. And that too optically active. Take your time and do it. What will be answer for this question? This time minimum carbon hydrocarbon. Spreha.
Sir, 6 carbon.
Okay. Astha.
Sir, I think 6.
Advik.
So same, so 6.
Tarun.
I'm getting 6.
Iha. Iha, you're not there? Eating?
The 6 only.
Okay. Can't see you. So minimum carbon hydrocarbon, you can draw 6. Okay. See, this is all hydrocarbon only, right? Now next question. Draw minimum molecular weight hydrocarbon that is optically active. अब क्या करोगे? Draw minimum molecular weight hydrocarbon. How to draw now? Minimum molecular
Sir,
weight.
6 carbon.
That's okay, but what is the hydrocarbon that you're drawing?
So you place the
6H8.
single bond with double bond.
So you have to minimize molecular weight this time. So see, this is the carbon. One I put hydrogen, then Spreha.
Then, sir, CH3.
Very good. Then
CH double bond CH2.
then
Then C triple bond CH.
very good. So why are we putting double and triple bond both? Because they save hydrogen for us. When you put double bond, you're saving 2 hydrogens. When you're putting triple bond, you're saving 3 hydrogens, right? Understand? Sorry, 4 hydrogens, right? So double and triple bonds are better choices than single bond. So we're not having CC single bond. We are having double bond and triple bond because we have to minimize the molecular weight this time. कितने लोगों को ये बात समझ में आती है? Is that okay? Raise your hand if it's clear. How this is helping you? Because if it is a single bond, in single bond there will be more hydrogen. No? If it is a double bond, I can save 2 hydrogens. So molecular weight will also come down. So the correct answer is this. 1 CH3, 1 double and 1 triple bond. Next question. Draw C8H18 which shows only one monochloro derivative. Draw C8H18 which shows only one monochloro derivative. कैसे करेंगे?
Sir, will it be 2, 2, 3, 3 methyl butane?
Yes, 2, 2, 3, 3 tetramethyl butane. Very good. So 1 monochloro means if you write the structure, it should be symmetrical. See, if I put any chlorine here, I put here, here, or here, or here, here, or here, they're all same because it's all A. Can you observe? So 1 monochloro means if I want to put any substitution on any of the hydrogen, Advik, is it clear? They are all same everywhere. You remember we've done ABCD writing and all? Okay. Same question, C5H12. How will you write? What is the structure that you will draw? Same question, C5H12. Now what's the answer?
Sir, 2, 2 dimethyl propane.
Very good. It should be this structure. Neopentane basically. Or 2,2-dimethyl propane. कर लेंगे? धृति? Advik, C5H12. C5H12 will look like this. Same question, C5H12 look like. This is A. All 4 are same? Can I say only one monochloro is available? कितने लोगों को दोनों क्वेश्चन समझ में आ गए? एक बार हैंड रेज कर दीजिए प्लीज. Excellent. Anyone having any doubt in this? कुछ भी प्रॉब्लम फेस कर रहे तो प्लीज बताइए. No problems? Draw C7H16 which shows only 3 monochloro derivative. अब थोड़ा करिए इसको. Maybe we can get more than one structures. Please keep your eyes open for that. C7H16. How many unsaturations are there? 7 plus 1 minus 16 minus 0 by 2. That is 8 minus 8. No unsaturations, right? No unsaturations are there. So now in this situation, you can have 3 monochloro derivatives. So you see this one, A here, B here, and these are C. That can be one option. Somebody can draw this also. A here, these two are B and these two are C. Somebody can draw this also. All three are A. This is B, this is C. This is also C. Correct? In all three cases, do you find that we have 3 monochloro derivatives? Anyone has drawn something else apart from this? One more can be drawn. चलो वो मैं आपका वेट करता हूँ, आपको ड्रॉ करके दिखाओ.
So can we do the like 3 on 1 carbon and the rest is one single chain?
3 on 1 carbon and
That's like in the second one, but yeah, like that.
3, something like this.
Yes.
Okay, this structure. ये आपका हो गया A, B, C, D. This is 4 actually. Check.
So want those to be BB or something.
No. See, if this is the case you're drawing now. These 3 are A. This is B, C, and D.
So isn't C and B same? Like
No.
they're not like that.
Because this is carbon, then again one more carbon is there. They're not same. See, there's no symmetry in this case, no? That's why we are not seeing the same in this case, right? They're different. See, in this, if Cl comes here, it's a different formula. There's a different formula altogether. Right?
Sir, it should be 3-ethyl and pentane.
Very good. It should be 3-ethyl pentane. Draw the structure. This structure. 3-ethyl pentane.
So 3 monochloro derivative means that like three such places where if we put the Cl, the formula it remains the same.
No. That's a trichloro derivative, which you're thinking. One place you have to put at a time. Okay?
Like
But
three
it
different
will give you 3
structures.
different options.
So in the first one, how are we doing it? In the first and
Let's say
second.
put Cl here. That is one option. Other option is you put Cl here or here. That is the second situation. If you put Cl here or here or here or here, all are same. If you have doubt, just see this now. Now see, they're same or not? A, B, B, C, 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 C. Okay.
Yeah, yes.
This is the last one. A in the center, B, 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 C, C, C. See the symmetry. Symmetry about this concentric part. Please mark. So now write down optical isomers. Now we're going to detail of it. Optical isomers, isomers under stereoisomers or stereoisomerism. Stereo means orientation, where orientation is different. So there are multiple terms which is called optically active, chiral, asymmetric or asymmetric center. What is special thing about optical active compound? Optical active compound can rotate PPL, प्लेन पोलराइज लाइट को रोटेट कर सकता है कौन? ऑप्टिकली एक्टिव कंपाउंड. Now, what is meaning of plane polarized light? Now, normally, if you think about a point source, you have the wavefront, which is spherical wavefront, because it will go in all direction, right, from a point source. Think about a bulb, right? So light can move from the center of the bulb in all direction, like a sphere, right? And the wavefront, basically, what is the pattern which is being cut perpendicularly is basically a sphere. So this is a spherical wavefront. When you make it polarized, we use something called polarizer. Okay. So let's think. Let's say the light is moving in all direction. You use this kind of device. It will move only in one dimension now. This is called PPL or plane polarized light. Now, what is the purpose of optical active compound? It will rotate clockwise or anti-clockwise. It will tilt the PPL clockwise or anti-clockwise. If it is clockwise, this is called plus or D or dextro. If it is anti-clockwise, L or levo. So dextrorotatory or levorotatory. Positive or negative. Fine. Or what we have done in earlier classes, remember R and S? If there is just one carbon, then same will be plus and minus. But if there are more carbons, you have to see. There can be 2R and 1S, but 1S can be very strong. So the overall thing can become negative. Or maybe 2R are more stronger than S. Then overall thing is positive. So based on that, you can decide what is the overall behavior of the compound. Make sense or not? Each carbon wise and overall structures value. Draw the structure, note on these pointers. So far we are just talking about optical active compound. Now we are talking about optical active compound will do what? How will you identify them? One idea was we have asymmetry, but how? What it is doing? So it can tilt plane polarized substance both clockwise or maybe anti-clockwise. And you can write D and L symbol, plus and minus symbol. Optical active is also called chiral. It is also called asymmetric center. They can rotate plane polarized light. Any difficulty in this? So now we have to learn all these terms. So first you make the index of it. Sir, आप लिख लीजिए एक बार.
So can you just show the last point?
Yes. Draw this index. So you're supposed to write down all the terms. Chiral center, chiral compound, a chiral compound with chiral center. I hope it is visible clearly. Center of symmetry, C2 axis of symmetry, C3 axis of symmetry, C4 axis of symmetry, C6 enantiomer, erythro, allene, ketene, spiro, bicyclo, plane of symmetry, pair of enantiomers. पहले इतने नोट कर लीजिए, फिर मैं नेक्स्ट लेके आता हूँ आगे वाले. Try.
So what is the fifth point?
Are you writing these names? How many of you have written the names? These terms? Top one done. These you already complete collision. So why are we doing index? Because once the index is done, then we'll cover all the terms and we can say that now you know everything properly.
So could you scroll to the first page once? I missed one. Just 1 minute.
Now this is all.
Thank you,
Is it
sir.
visible?
Yes, sir. Thank you, sir.
यहीं पे छोड़ देता हूँ मैं, यहाँ पे सारे दिख जाएंगे आपको. Racemic mixture, mesoform, 100% racemization. Extent of racemization, enantiotopic hydrogen, diastereotopic hydrogen, 3 isomers. Retention of configuration, inversion, partial flipping, pure form, stereogenic centers. Presence or absence of POS, alene system, ketene system, spiro system, bicyclosystem, RS nomenclature, Fisher projection, Newman projection, sawhorse, wedge dash, DL system, DL parent naming system, capital D capital, this small d smaller. Optical purity, specific rotation, resolution. Okay. How many of you have completed writing this? Raise your hand.
Just
How
2
many still
minutes.
writing? Okay, complete courage. So once we cover all the terms, then you're ready for your mains as well as advanced exam. दोनों यहाँ से हो जाते हैं complete.
So can you zoom in a bit? So zoom in, zoom in.
अद्विक इसी में आपका डाउट था आई थिंक जो का कॉल आया था उसमें. अद्विक.
हाँ सर हाँ.
So I haven't written from Spyro system. Could you scroll up?
Done.
1 minute. So flipping and what is that? So
Flipping, pure form of enantiomers. Stereogenic centers. Presence or absence of POS, presence or absence of COS.
1 minute.
Okay, now see, few things we already know. For example, the first term, what is chiral center? You know that? So whatever you know can mark that this is done. Chiral center we know. Everyone, can we mark chiral center is done? Okay. Chiral compound, a compound which is showing chirality, right? Can be chiral compound. Or basically chiral center, you understand. Chiral center is that carbon with 4 different groups. N plus with 4 different groups, right? Can there be a chiral compound without any chiral center? And can there be a chiral compound with chiral center? ये भी आपने नहीं किया हुआ है, इस पर भी डिस्कशन करेंगे. So compound showing chirality without any chiral center, that is also possible. And a chiral compound even with a chiral center, that is also possible. Okay. ये भी अभी आपने नहीं किया है, ये भी आपने पूरा ठीक से नहीं किया है. Plane of symmetry we have done. Can I say plane of symmetry we know? Yes or no?
Yes, sir.
Come to this side. Center of symmetry we know. C2 axis we know. C2 axis means C360 by 2. Basically, how many degrees? 180 degrees. C360 by 180 is C2 axis. 360 by 120 is C3 axis of symmetry. All right. C4 axis, 360 by 90. C6, 360 by 60. So where will you observe C2 axis of symmetry? Anything which is like this. C2. C3, take this triangle, line passing perpendicular to the structure. C4, take a square or cube, this one. C6, are you getting this? Have we talked about these things earlier or not? How many of you are okay with these terms? Raise your hand. We've done it earlier. There's nothing new I'm talking about, right? Okay. Enantiomers अभी हमने नहीं किया है, एराइथ्रो नहीं किया है, एलीन नहीं किया है, कीटीन नहीं किया है. ठीक है, से कर लेंगे. Come to the next part. Pair of enantiomers नहीं किया, diastereomers नहीं किया. Mesoform. Have we done mesoform? Internally cancellation of R and S, equal and opposite. But anyway, इसको भी मैं एक बार डिटेल में करा दूँ. इसको फिलहाल हटा दो. Now tell me, do you know what is bicyclosystem? This we have done in IUPAC. And we have done Spiro system also in IUPAC, right? Spiro and Bio. These two names, you know. Spiro is the ring, where the ring is joined at one common point. Have we done RS nomenclature? We have done RS nomenclature. Writing 1, 2, 3, 4, moving 1, 2, 3, ignoring 4. LPGs towards you, change the number. LPGs towards away from you, keep the numbers, right? Fisher projection, we have done. Newman, we have done. Sawhorse, we have done. Wedge dash, we have done. On this side, रिटेंशन ऑफ कॉन्फ़िगरेशन, इन्वर्जन, पार्शियल इन्वर्जन, फ्लिपिंग, ये भी कुछ भी नहीं किया हुआ है, तो ये आपका सारा पेंडिंग है. चेक कर लीजिए. Okay, so we'll like do one by one all the remaining terms. Take a small break of 10 minutes. We start at 6:10 and we will complete maximum things. Let's see how much we can do in the today's class. Okay. 6:10 we resume. All right, let's start. So first term, optical active, chiral or asymmetric center, or center of asymmetry. We have done this. Anyone having any doubt in this part? Is it clear? Write the heading chiral compound. Compound may or may not have chiral centers. So any compound which is having some kind of asymmetry, even without presence of chiral center, can also be chiral compound. So write down chiral compound. Compounds may or may not have chiral center. Very important point. So far we have talked about compounds having chiral centers. Now we are talking about may not have chiral centers. Even then compound can be chiral. Example is asymmetric alene system. What is alene? Please draw the structure. This group is known as alene. C double bond C, back to back two C double bond C, is that called alene system. Now the special thing about the system is this and this p orbitals are perpendicular to each other. Please note down. These are perpendicular to each other. So if you take this axis, can you find symmetry? Yes. If you take the other axis, let's say the other plane, this plane, you can find symmetry. Either way it is symmetrical or not. But what if the same structure is existing where the groups are different here? अब क्या करो? अभी ये और ये. There are two different situations. We can't get symmetry now anyway, right? Iha, Tarun, Ritu, please turn on cameras. Spriha also.
Sir, I'm there, but
Yeah, one second. I'll turn it on like 5 minutes.
So compounds may or may not have chiral centers like alene system. Look at this example, G1, G2. G1, G2. They should not be same. If they are not same, then if you take mirror image of this structure, it will look like this. And these two structures which you have drawn here, G1, G2 and the other structure, if you try to place one above the other, it is not going to be feasible. It won't come. For example, अगर आप सोचते हो कि नहीं सर इसको मैं इसके ऊपर रख के देखता हूँ, हो जाएगा. Let's try. So if I keep G1, G2 as it is, so I'll bring it like this. Now you just observe what will be the placement of your G1 and G2. This is G1, G2. G2 will come here and G1 will come here. Think when you try to place it. That means they are non-superimposable mirror images, or which is also called chiral pairs. So write on this word. Chiral centers are not necessarily required. Okay. Compounds may or may not have chiral centers. Like alene system, asymmetric systems can be there. All right. Just take note of it. So non-superimposable mirror images, pair of enantiomers.
Can you again repeat it once, like this part after you drew the mirror image thing after that?
So if you try to keep this mirror image on the actual compound, it will not be superimposing. It will not be coming one above the other because G1 comes in G1, G2 comes in G1, G2. But see this G1, G2 part. इधर पे G2 आएगा, इधर पे G1 आएगा. Advik, can you observe? So they're not coming one above the other. They're not overlapping. Look at this example. If it is G1, G2, in this case, second example, and this is G1, G2. Let's try to put here. G1, G2 overlap हो गए. But ये G2, G1 क्या है? इसके ऊपर आएगी? G1 के ऊपर G1 और G2 के ऊपर G2. Answer is no. Just visualize. What is the plane? And what it's doing actually, right? So we just bring it here. G1 will go down and G2 will be up, right? So G2 will be here and G1 will come up. Think. If you rotate about this axis, pick G1, G2 here, then this G1 and G2 will not be in the same place, right?
Okay, fine.
So this is called chiral compound without having chiral centers. Chiral compound without having chiral center. Next part.
So
A chiral compound with chiral center. How will you draw that? A chiral compound with chiral centers. Can be a meso example. So meso example you have done earlier. Let's say COH, COH, HOH, HOH. Can you recall these kind of cases we have done earlier? Where we looked forward to get some kind of plane of symmetry inside the compound, where H cancels H, OH cancels COH, right? Internal plane of symmetry. Internal cancellation. Net optical radiation value will become 0 in such cases. So that is called meso. कितने लोगों को meso ध्यान है? Last class में किया. No, even we have done this case also, if you recall. If you're given this structure, if it is, let's say structure B, this should be B. If this is D, this should be D. This is E, this should be E. Then that is also meso. Which याद है? Last class में किया था. Exact opposite cases. Exact opposite cases. If you rotate the structure by 180 degrees, the structure will modify as E, D, B, B, D, E. ऐसा दिखेगा, right? Check कर लीजिए. D इधर होगा, E इधर होगा. B, E, D. Can you get that? So once you get this structure after rotation of 180 degrees, see from this angle. So what do we have? We have B, B, E, D, E, D, which is a mesoform. Yes or no? All this discussion has happened in the last class. In case you have missed the last class, please revise. कर सकते हैं? So see, this is meso. Internally compensated structure, meso. Equal and opposite impact of chiral centers. CH3HOH, CH3HOH, cancelling each other. One is S, other is R. कर पाओगे ऐसे cases? S and R equally, because the groups which are present here are giving you same magnitude of S and R in a way. Same impact of S and R, right? Because of the same arrangements. Now look at this structure. Top one is S, lower one is R. Okay. And now we are keeping this as S and R. I'm just changing the middle one. Are they same? Are the same structure? Answer is no. यथार्थ जी अब आ रहे हैं आप? किधर रह गए भाई आज? यथार्थ. Okay. So this is meso. This is a different type of structure, right? Not the same structure. Be careful. OHH, HOH. It's not the same because in this case, HOH, HOH same. HOH, HOH same. But this middle one is not same. So they are different structures altogether. Can I call them different mesos? Yes. Okay. Are these meso? CH3 on top, C2H5 at bottom. HOH, HOH. OHH, OHH. Why they are non-meso? Because top and bottom are different. Had it been CH3 here also, then this has been your plane of symmetry. CH3 here also, this has been your plane of symmetry. Is it clear? Because of CH3 and C2H5, it's not meso. The groups are not same. How it can be meso?
The first one is me.
Hmm?
First one is me.
The first one is a meso. Very good. But these are two different type of mesos. This meso is different from this meso. Right? Here, they are different, but they are not meso. Are you understanding? And the logic is these groups are different, not same. So how it can be meso?
So, but the mirror image is correct only, right? So, isn't it based on the mirror image or like?
Yeah, so mirror image is there, that's correct. But having said that, there is internal plane of symmetry. Is it available? Do we have this? No.
No.
So it can't be meso.
Fine.
So what is that you have to look forward in a meso? Number one, a plane of symmetry, internal cancellation, and optical inactive structure. I repeat, a plane of symmetry, internal cancellation, and an optically inactive structure. You have to observe these three things. Okay.
So can you show those examples again? First two.
Yes, Tarun.
So can you just show those examples again? The me, so not me.
कर लेंगे. Any doubts, any queries? Anything you ask? Look at these examples. How to get C3, C2 and all. We have discussed earlier also. Plane of symmetry also you have seen. So look at this structure. If it is HOH, it is HOH. I have this plane of symmetry. And since your plane of symmetry, the compound is optically inactive. As soon as you prove there is a plane of symmetry, there is a center of symmetry, compound is optically inactive. Look at this point. There's a plane of symmetry, inactive. This compound. Is there any symmetry? Answer is no. So it is optically active. Look at this compound. Is there any symmetry? Batai. What if we take this plane? Do we have plane of symmetry?
Yes, sir.
यहाँ पे हो सकता है ना? अगर ये प्लेन ले लिया जाए तो इस प्लेन की बात करूं. So about this plane, you can get optical inactivity. Look at this structure. Here you have center of symmetry because OH down, OH up, H up, H down. What is plane of symmetry? If you put this plane itself, can we say this is a plane of symmetry? One is enough to show it as optically inactive. Look at this example. This is plane of symmetry. Do we have any center of symmetry? No, but one is enough to show it optically inactive. कर लेंगे? So try to figure out optically inactive. That means you have to figure out at least one center of symmetry or one plane of symmetry.
So can you show
Any
the
of these things.
conditions for a meso?
For meso. Meso is internal plane of symmetry.
So now the conditions you showed some three conditions.
Plane of symmetry, internal cancellation, optically inactive.
Sir,
Yes.
can you scroll up? I had a doubt.
बताएं.
Sir, in that OH, and there are like two H and OH1. In that one, is it optically active or inactive?
See, this structure you're asking.
Yes.
So in this structure, if you see, do we have a center of symmetry? Do we have a point here? Is it center of symmetry? No, because this is H above, this is also H above, this is also above, right? So the next question comes, do we have a plane of symmetry? And if yes, which plane of symmetry? Which plane you have to consider, right? So just observe this case, for example, this one. Can we say we can take this plane? So in this plane, OH, HOH, they're opposite. Hence, this is optically active. In this case, if you take this plane, for example, this plane, H, and यहाँ पे लिखा हुआ है आपके पास यहाँ पे OH होना चाहिए. देखो यहाँ पे H लिखा है, ध्यान से देखो. This is H. Was it earlier OH? Yeah. So OH, if it is OH, do we have this symmetry? Check. This plane of symmetry.
Yes.
Okay, so this should be optically inactive. This is inactive, not active. Okay, because you have plane of symmetry. Fine.
But the plane of symmetry, like in the same structure, we will take two different planes and then see like if
Plane of symmetry is basically you can find just one plane about which the structure is symmetrical. Just one plane is enough to prove it optically inactive. Just one center of symmetry is enough to prove it optically inactive. Clear, Asta?
yeah, yes.
Which
You
is the
don't want
plane?
min.
So which is
Yeah.
the plane for that one?
Yeah, this plane, any plane you can take. See, you can take this plane also. Okay, somebody can take this plane. Right? That depends which one you want to take. But it will remain optically inactive. So simple theory is, if you can prove that compound has plane of symmetry or center of symmetry or both, then compound will be achiral or optically inactive. Compound will be achiral or optically inactive. Or we can say absence of POS and COS is chiral. कर सकते हैं. Same discussion. You can note it down. Write down Racemic mixture. Write down the heading Racemic mixture. Equimolar mixture of pair of enantiomers represented by plus minus DL RS, RSSR, RRSS, RRRSSS combination. इसमें एक में ही सारी बात हो गई. So equimolar mixture of pair of enantiomers represented by. What is enantiomers? Non-superimposable mirror images. Okay, as you have seen, alene system or optically active centers, which are non-superimposable. So equimolar mixture means if I have, let's say, D and L, 1 mole each. Externally, they are becoming 1:1. That means you can eventually say this is an optical inactive mixture, because whatever is the impact of one, exactly same is the impact of other, with opposite rotation methods, right? Okay. So equimolar mixture of pair of enantiomers, you can say plus minus DL, RS, or there are two chiral centers in RSSR, two are RRSS, or three triple R triple S. 1:1 mixing, externally compensated optically inactive mixture. Which was internally compensated? Anybody?
So what does 1:1 mean? Like,
Equimolar mixture, दोनों के एक मोल.
okay, fine.
Okay. एक बार कैमरा ऑन करेंगे तो बहुत तेजी में समझ में आएगा.
तो नहीं, वो कैमरा, आई मीन वो नेट थोड़ा सा धीरे चल रहा है.
सबके नेट सही कराने पड़ेंगे एक बार.
अरे सर, वो मेरा तो अभी एक ही बार हुआ है.
ओके.
Sir,
इया
what?
जी का कुछ सही नहीं हुआ. इया का पूरी क्लास निकल गई. कैमरा ही नहीं ऑन हुआ. नेक्स्ट क्लास से मैं अलाउ नहीं करूंगा. मैं जो भी इसका कैमरा बंद है, मैं बिना कुछ पूछे सीधे आपको रूम से बाहर कर दूंगा. यानी फिगर इट आउट, आप कैसे करते हो, क्या करते हो, और रिकॉर्डिंग देख लेना अदरवाइज. तो नेक्स्ट क्लास से, मेरी क्लास में तो स्ट्रिक्ट रूल रहेगा, आई विल नॉट आस्क एनी टाइम. कैमरा आपका बंद है, मैं आपको सीधे यहाँ से एक ऑप्शन होती है, करके दिखाऊं. यहाँ पे एक ऑप्शन होती है, पुट इन वेटिंग रूम, बस. सो नेक्स्ट क्लास के पहले प्लीज आप फिक्स कर लीजिए अपने जो भी कैमरे की दिक्कत है, नेट की दिक्कत है, जितनी भी समस्याएं हैं से गुजर रहे हैं आप, उन सबको सॉल्व कर लीजिए प्लीज. ठीक है. इट लुक्स वेरी बैड बिकॉज आप क्या करो मेरे को नहीं पता, देख भी नहीं रहे हो, बोल रहे हो, कभी नहीं बोल रहे हो, कभी सो जा रहे हो बीच में. धृति देखो, धृति तो गायब ही हो गई थी, अभी लौट के आई है. Where were you, धृति?
So sorry, the battery, like, so the computer shut down.
ओके. अलग अलग दिक्कतें हैं, कैमरे की दिक्कत है, नेट की दिक्कत है, लैपटॉप की दिक्कत है, बैटरी की भी दिक्कत आ गई. राइट. ओके. ईहा, आपकी क्या दिक्कत है?
Sir, I turned it on and it was coming gray. I started in the class, in the starting of the class, but then suddenly.
You exit and join, it will be fine. Advik, what's your problem?
मेरा भी, I changed it from Wi-Fi to my phone's hotspot for now, like for some time.
तो एक बार एग्जिट करके एंट्री करिए, देखना शुरू करिए.
So what does POA mean?
एक बार एग्जिट करके एंट्री करिए, फिर बताता हूँ व्हाट इज पीओई. देखो कितना अच्छा काम कर रहा है कैमरा.
नहीं, वो नेट एकदम से बीच में चला जाता है.
POE means pair of enantiomers. And what is enantiomers? Non-superimposable mirror images. Okay? Non-superimposable mirror images, like your hands. So they can be mirror image, but you cannot keep one above the other. Okay? It's very rare. Right? It's not possible. So it's a non-superimposable mirror image. Externally compensated optically inactive mixture. What was there in mesoform? Mesoform was like this. Some RS, where this R and this S are cancelling each other, right? They're cancelling out each other, exactly equal and opposite, with the same set of groups. All right? Look at this example. CH3, COH, HOH, CH3, OH, HCOH. So it's a mirror image. One is X, other is Y. So can we say X and Y are enantiomers? Yes. X and Y are non-superimposable mirror images? Yes. X and Y mixture in the molar ratio 1:1 can be called Racemic mixture? Yes. The above mentioned mixture is optically inactive due to external compensation? Yes. आ गया? क्या सारे पॉइंट समझ में आ रहे हैं आपको? If 1:1 ratio exists, we consider it and call 100% racemization. This is called 100% racemization case. When both are exactly equal in numbers, 50 moles इसके हैं, 50 moles इसके हैं. So जो racemic mixture बनेगा वो completely pure होगा. Basically, it will have both the components in equal number. 100% racemization. Okay. Anyone having issues with any of these 4 white pointers and the diagram? Please ask your doubts. Enantiomer समझ में आ गया? Enantiomers is basically mirror image which is non-superimposable. Done?
But sir, if we flip it, then won't it be won't we able uh, won't we be able to impose it on the other one?
So is it a planar structure? Keep that in mind. Is it a planar structure? No, it is like this.
Oh no. Acha, okay.
Now just try to flip and put it.
Now it won't work.
Understood? Will it come? It won't come. That is why, now you answered yourself. That is why if it is a planar structure, even with this kind of setup, it's also optically inactive because planar things are optically inactive. We know that. Planar things will have their own planar symmetry. That is the reason why they are not showing optical active. Is it clear, Asta?
Yes, sir.
Okay. Now look at this example. Let's say we have 80% R and 20% S. So out of 80% R, if I take 20% R this side, this 20% S and 20% R will become Racemic mixture. And the 60% will remain as a pure R. Is it making sense? This math's making sense? Let's say you have 8 moles of this, 2 moles of this. You take 2 moles of this out, this is 6 moles. So out of total 10 moles, this is 60%, this is 20%, this is 20%. Make sense? So can we say we have 60% pure R and the remaining 20% pure R and mixing 20% with S, we get this kind of Racemic mixture. So how much is the contribution of this? 40 units. Out of total, how many units? 100 units. This is called 40% racemization. What is 100% racemization? When we have 50-50. What is 60% racemization? When you have 30-30. What is 20% racemization? When you have 10-10. Is it clear?
So can you explain this one again?
Okay.
Yeah.
This is clear, Advik?
No, so this one only, this part only.
This is given. R and S, 80 and 20% are given.
Mhm.
So this 80% out of 80, let's say 60 and 20, you can break it up.
So
This
how?
20. No, I'm saying if you break it up, right? And
Okay.
if you get 20% of R and S together, what is it called?
So
R
that
and
will
S mixture is
yeah.
Racemic mixture.
Mhm.
Total, how much unit you have taken out of 100 units?
Out of 20, 40.
Very good. This is called 40% racemization.
So can you even break it into 40 and 40, like for the R?
But S should be 40, no? S is just 20.
Okay, so it should be equivalent to the S, like the other smaller part.
Yeah, R and S should be equal. Then only you can call it Racemic mixture, no?
Okay, fine. Then fine.
So if you break as 20-20, this is 60, this is pure R. My answer is 40% racemization.
Fine.
Next heading, diastereoisomers. Non-superimposable mirror images. ये हो गया non-mirror images. And आ गया यहाँ पे. Non-superimposable, non-mirror images. So just see the example. One example can be cis and trans, okay, which are geometrical isomers, but they are also considered as diastereoisomers. Can we also say partial mirror image? Because one part is having mirror image, other is not. This is same. This is mirror image. It's called partial mirror images. Look at this example. This is having mirror image.
So 1 minute, can you scroll
Just
down?
dollar same.
Can you
So
scroll
it's
down?
a diastereomers. It can be one of them, two of them, three of them, but not all of them for sure. Okay.
So can you scroll it up?
Yes. Cis and trans are geometrical isomers, but they are also known as diastereoisomers because they are non-superimposable, non-mirror images. Hence, in a way, diastereoisomers. Look at this case. 2 hydrogens, 1 OH. 3 hydrogens. 3 OH one side. 2 OH, 1 hydrogen. Top is CS3. Bottom is C2H5. 1, 2, 3, and 4. Connect and tell me. 1 and 2. Just check this structure with this structure. What are these two? Everybody?
Diastereomers.
Very good. How about 2 and 3? These two. OH, 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 H, 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 H.
Enantiomers.
Sure.
Pair of enantiomers बोल दो. POE. What about 1 and 4?
Enantiomers, no pair of enantiomers.
1 and 4. ये दोनों का तो मिरर इमेज मिल रहा है. इसका भी मिल रहा है क्या? इसका भी मिल रहा है. अब बताओ. 1 and 4 क्या है? मिरर इमेज, मिरर इमेज, मिरर इमेज. सभी की मिल रही है. So can I say pair of enantiomers? बताइए. 2 and 4. 2 and 4. Check.
Diastereomers.
Very good. 3 and 4.
Diastereomers.
नोट कर लीजिए. Try.
Can you scroll up?
Done?
So 2 minutes or 2 minutes.
हो जाएगा. Now look at this structure and draw all these forms. First one is meso. Look at the fissure. Second one is also meso. Look at the sawhorse. Third one is also meso because see the opposition, top, bottom, right, left, left, right, same groups. Look at this one, that's also meso, top, bottom, opposite, opposite. So are you in condition to recognize meso in any of the formats? सॉर्स में आगे ढूंढ लोगे, न्यूमैन में आगे ढूंढ लोगे, सॉर्स में टिल्ट करके आगे ढूंढ लोगे, फिशर में आगे ढूंढ लोगे. Can you figure it out? So just to make your job easier, please draw all four structures once. और ठीक से बनाना, गलत मत बनाना. Clear? Anyone having any confusion on this part? Advik, Tarun, Ritu, Dhriti, Spreha, Iha, Asta. Everybody, any doubts? Can ask. Done? Draw कर लिया? चलिए आगे देखते हैं. Now, you know meso. Now, meso का एक close to meso there is another term called erythro. Okay, first meso should be clear. So meso is what? Top and bottom. Everything is matching. That's meso. In erythro, everything will meet be like matched exactly same, but something is different. So see, CS3, yes, HH same. इधर OH से इधर भी OH आता तो क्या होता meso, but इधर क्या किया? BR. So what will happen? Its mirror image, if you draw it, it will look like this. Is it having symmetry? No. Are they pair of enantiomers? Yes. So the pair of enantiomers which are drawn in this way, where it could have been meso if this number is same. Right? Can you understand this part? That is known as erythro. In simple words, erythro is, we can understand, one shot in meso. One shot less than meso. यहाँ पे OH होता तो meso होता. BR होता तो भी meso होता. OH BR है. Okay. Is it making sense? Check this
because
example.
it's not same compound, it's not.
Yeah, this should be same. Since it is not same, it is one less than meso. I'll call it erythro. So these are erythro pairs. These are pair of enantiomers which are called erythro pairs. Is it optically active? Yes, it is optically active. There is a compound called erythrose in sugar, which is the reference for this name. This is the structure. CHO, CH2OH, HO, HO, HH.
Sir, how is the second example erythroisomer?
See, in erythrose, what is required? Everything should be same, right? Except what? One position.
Position,
So
yes.
see, had it been CHO here, don't you think it is erythro? It is meso?
Yes.
Or had it been CHO here, this is being meso? This would have been meso.
Yes.
So who's stopping you? Just one chain. Or this is, let's say, CH2OH, then it is meso. Or this if it is CH2OH, then it is meso. Yes or no?
Yes.
So just one change and you get the meso. That is known as erythro. कर पाएंगे? यहाँ से फिर नेक्स्ट क्लास में देखते हैं इसके आगे. Okay. Take care. Bye-bye.
Thank you, sir.
Thank you.
Thank you,
Thank
sir.
you, sir.
Please fix your net, battery, and laptop.
Thank you,
Bye.
sir.